Hello again, this is Michael Hicks with your final exam practice session. I'm just going to go through the two statistical models here, tell you what I'm looking for in this practice exam. You'll also get the paper copy or the electronic copy of this test, which I've actually written out my results to, and the file with the data in them as well. And that should give you pretty much everything you need. The last of the two section 13 or videos cover all of these material as well as the review of the statistics part. So that gives you kind of what you need to know. But this is just the exam for you to see that. So we begin, the first question here is I'm looking for you to make a comparison of a couple of means and describe what they talk about. So let's dodge over here to the data real quick. And what I have is the same data set that we've been working with. This is from Weinstein, Warnell, and Hicks 2020 study of quality of life. And what we're looking at here are just a random set of data: population, median age in county, median home value, total number of households, the number of marriages in 2010, the divorce rate in 2010, the number of housing units, and the number of vacant housing units. And so the first question is, give me a couple of means. And so I'm going to pick this, median home value. So I'll go to home data. And recall, if you don't have the data analysis work pack and set up, that is going to be far more difficult. I want to do the two-tailed sample, assuming unequal variances. And the reason I do this is in statistical work, the least restrictive assumptions, which is a code word saying the anytime you make an assumption that limits what you can do to a very narrow case, that's a mistake. So assuming unequal variances is more relaxed assumption than equal variances. And so what I want to do, and I've already typed it in, the first variable range is going to be median house values. We'll zip down here to Mississippi, right? I'm sorry, that's Alabama. The second one will be the same data set, and I'll pick that up with Mississippi. Notice how I have frozen the work plane so that I can see the top label here. If you're not familiar with Excel, that's the first thing you want to do. So now we have this, right? I'd like to have it output somewhere that's easy to see. I'll hit OK. That gives me the two-tail test, right? And so I have a t-statistic, I have two means, I have two variances, number of observations, and the t-statistic says you can reject that they're of equal means. So that's the first of the two tests. You do precisely the same thing again. We'll just pick another unequal variance. We'll pick a different data. Let's look at the divorce rate, right? So we'll pick divorce rate in Alabama. Pick the divorce rate in Mississippi. It doesn't matter as long as you enter the files. It doesn't matter if you start from the bottom or top. And we'll do an output range there. Okay. One of those variables is non-numeric. So let's pick different variables. Let's look at marriages. This is part of the data generating process here, right? No, let's do median age in county. Sorry. There, we have two median ages, t-statistic, p-value very small, t-statistics 1.65. So, or I'm sorry, that's the one tail. The two tail t-st is at 4.65, so they are different ages. And so that really gives you the answer that I'm looking for. I'm going to go back to the actual practice exam. I have means of median age and median home value, right? And very similar results. I think I actually overlap the data in them. And it gives you the answer that I'm looking for in that version, okay? And the second question asks a very straightforward issue. I'm looking for data on the home for you to do a couple of reduced form regression models. This again is multivariable models. And I'm not really looking for anything important here. I'm looking for you to be able to do this. So let's go back to the spreadsheet itself. I'll eliminate both of these. And we'll do a regression. We go back to the data analysis, and now we go back up to regression. All right, the Y range, I'm going to have median home value for Alabama. And then the X range, I'm going to have all of these variables. Total number of households, marriages, divorce rate, number of housing units, and number of vacant units. Let's see if those can predict what those do to predict values. Output range. Rats. Sorry. I want the output range to be here, and I want the input range to be the median home value in Alabama. Okay. That's regression 1. And I'm going to actually copy this, paste special, transpose it, so that gives me the variable names there with which to interpret, right? I'm going to do exactly the same thing. I'm going to do another regression model. This time I want the median home values. Start in Mississippi. And then the output range I'm going to have as the total number of households, marriage, divorce rate. So it's the same regression for both states. We're just going to compare states. And then I want the output range to be different. I'm going to go down here. There's some non-numeric data. I just do variables for this example. And here we have. So let's compare these two. We have, this is where we had the problem, the number of vacant housing units. One of those values is wrong. So we have two variables here. T-stats on this one is good. So I'm going to highlight the ones that are good. We'll go up to this one, T-statistics. None of those are good, right? So we don't have a very robust model here other than intercept for Alabama, but we have values that work when the two variables for Mississippi. The two variables are these, are total number of households and marriages. This is obviously fairly strongly correlated with that. So what I'm looking for, and we'll go back to the exam results that I provided you, right, are this. Here they're same thing. It looks, of course, because we did the same thing. Our Alabama demonstrated no meaningful relationship between any of the coefficients except the intercept and median home prices. Despite that, the regression was statistically significant with an F that was acceptable at the 1% level. Mississippi total number of homes was acceptable there. I did all four, however I was able to. And that gives you some sense of how the regional variation may occur. And so that's really what I'm looking for in the statistics component, is for you to be able to do those statistical tests that I ran with in the first portion of the class. Again, it's the mean compared to two sample means or two sample variances. Those are really what I'm looking for, and the ability to do regressions, because regressions are going to be ultimately the source of most of the empirical work that you do in the MBA course. It is the empirical bread and butter. It informs algorithms. It provides controlled effects of marketing. It gives you worker characteristics that you should be focusing on, or leader characteristics if you're in HR. It gives you logistics pricing models. It is the regression model is used in futures or options pricing. It is really the workhorse of the business professional or the economist or the finance or accountant or marketing person. So it's really what most of you will spend a lot of time on. But we also, because this is an introductory course, would like you to see the market for, see the basic market models, the economics, so that you walk into it with an understanding of how economists are describing markets. I think that's a critical key of business components, even if you're never doing macroeconomic forecasts. Simply understanding what and how economists think through this is important. So the first market model that we have here, and I'll just read this quickly, which you can do along with me, says illustrate, that is draw, the effect on equilibrium price and quantity of an increase in the price of public transportation. And then a second graphic, illustrate the effect of an increase in steel and aluminum tariffs on the equilibrium price and quantity of automobiles. And then a third graphic, illustrate both effects. So the idea here is that we're looking at different things that happen. So the first one is simply supply and demand for public transportation. So an effect of equilibrium price of an increase in the price of public transportation. So if there's an increase in the price of public transportation in the car market, that causes the demand for cars to go up. So there's less substitutability here. So this is the price of a related good, a substitute good. So the price of the substitute goes up. That causes the demand for this product to go up. And we go from originally from PQ to P prime, Q prime. Very simple, straightforward answer, and that the increase is the price of public transportation increases the demand for automobiles because they're related goods, they're substitutes. Right. The second one was what happens if there's an increase in the steel and aluminum tariffs, right? Well, that's a supply side effect. So an increase in aluminum tariff would mean at the same price there would be a shift to the left. The supply would go up, but you see the price go up and the quantity supplied reduced, right? Now you put the two together, and what you see here in this model is the uncertainty of price and quantity effects moving in opposite directions. You see the demand going up, the supply moving to the left. So we know the price is going to go up, but we don't know what's going to happen to quantity. I've drawn two equidistant parallel changes in demand and supply. That's obviously a rare condition. And by the way, in art, it happens if we look at studies of people drawing, this is what we would get. But this is a indeterminate price. That's the straightforward answer. The next question is, which product is more likely to have a higher elasticity of demand, insulin or sodas? Right? So think about it first conceptually. The elasticity of something really reflects your ability to change your consumption based upon the change in price. So if the price of sodas goes up, you can relatively easily change your demand for it. It's not something most of us need. Insulin, on the other hand, is going to have a very non-price responsive demand or inelastic demand. And so the demand, if there's a price increase for insulin, we'll see a very small change in quantity. And so I have two demand curves. The first one is the demand for soda. The other one is the demand for insulin. So if we had a price change from a low price to a high price, right, that would cause a big reduction in the demand for sodas, but a very small reduction in the quantity demand for sodas, a very small reduction in the quantity demand for insulin, right? And then my next to last question is illustrate a monopoly model and show the effect of a decline in production costs on monopoly price.